Hello and welcome to Algebra Unit 1, Concept 2, Lesson 7. We are almost done with this concept. So remember, you should be filling in your guided notes as we go. Scholars will use inequalities to model real-world situations and then solve those inequalities to find sensible solutions to the situations. So in the real world, we often don't have things that we need to be equal to. When I go to the store, I don't say I have to spend $50, right? I say I have to spend less than $50 because $50 is all the money I have. Does that make sense? I might say that I need something to weigh more than a certain weight. Often in the real world, like I said, it is not that we have to equal something. We need to be less than. We need to be less than, greater than. Notice I'm using THAN because we are comparing something. It is not THEN. Less than or equal to. Or greater than or equal to. Okay? And just so you know, if you want to get these symbols, all you have to do is hold the Alt button and then also select that key that has that on it, and that will give you the greater than or equal to sign. So let's look at a real world inequality. You are packing for a trip, and in order to avoid an overweight bag charge, your suitcase must weigh 50 pounds or less. The empty suitcase weighs 5.4 pounds. And yes, by the way, LB is how you abbreviate pounds. And you plan to pack one pair of shoes that weighs 2.6 pounds. Toiletries that weigh 3.2 pounds. And several changes of clothes. If each change of clothes weighs 1.8 pounds, how many changes of clothes can you pack? So this right here is my variable. So what letter do we want to use for it? I'm going to use our good old-fashioned X. I like X. So let's talk about this. Which things have to do with how many sets of clothes I can pack? Well, each piece of clothing weighs 1.8 pounds, right? But that's not the only thing I'm packing. I also have to keep track of the weight of my suitcase, the weight of my shoes, and the weight of my toiletries. So, and all of that must weigh 50 pounds or less. How can I represent that? So, let's try this equation. I'm going to say that 5.4, my empty suitcase, plus 2.6, my shoes, we check them off as I do them, plus 3.2, make sure you tell us plus 1.8x must be less than or equal to, because it can weigh 50 pounds or less. Has less than or equal to 50. Well, there's my equation. So let's look at how we would solve this equation. Okay, you notice I gave you the same format that we use the other ones. We are going to say what we're doing for each of these. Well, the first thing I'm going to do is I have all of these like terms right here that I can just put together. So, my first line, I'm going to combine like terms. And remember, my like terms are all the terms I have here that do not have a variable. So, these 3 terms. So, I have 11.2 plus 1.8x must be less than or equal to 50. So what am I going to do next? Well, I'm going to use my subtraction property of equality, and I'm going to subtract 11.2 from both sides. So I have 11.2 minus 11.2 plus 1.8x is less than or equal to 50 minus 11.2. So when I combine my like terms again, I get 1.8x is less than or equal to, less than or equal to 38.8. Okay, so the next thing I'm going to do is I'm going to use my division property of equality. I'm going to divide both sides by 1.8. Remember, I'm treating this just like an equation. So I've got 1.8x divided by 1.8 must be less than or equal to 38.8 divided by 1.8. When I simplify this, I get x must be less than or equal to 21.5 repeating. Remember that repeat bar over top just says that the 5 keeps going on forever. So what does this mean in this real world situation? Well, obviously I can't pack 21.5 outfits, so then maybe I can pack half an outfit. But it's telling me I can pack less than 21.5 outfits. So how can I represent this as an answer? Well, we display our answers to inequalities on number lines. So you notice I have a blank number line here. It's just blank. Well, my answer was 21.5. So what I'm going to do is on this number line, I'm going to label one of these 21.5. Okay, it does not matter where I put this really. I can put it anywhere, but every increment must be the same amount. So if I label this 21.5, if I do other labels, I need to make sure that they are the same amount. Maybe I put a 0 down here so you can see the 0. So I know 1, 2, 3, 4. So 1, 2. So I know 1, 2, 3, 4 gave me 21.5. So let's count another 1, 2, 3, 4. Would give me double that, which would be 43 if I wanted to label more than one. So first thing we're going to do is we know that our answer is x must be less than or equal to 21.5. Okay? So I am going to put a dot at 21.5. We either use open dots or closed dots, filled in circles. An open circle means as close as I can get, but not equal to. So not that number. A closed dot means we are including the number, including that value. So in this case, because it's or equal to, I'm going to fill in this dot. And then I'm going to shade one direction. So I choose the direction by saying, okay, so which way is correct? So I can pack less than 21.5. I cannot pack more than. So I'm going to shade this way, including shading the arrow. And that's how I demonstrate that any answer here is correct.